Hello friends, in our previous video we have seen the concept of NFA, which is a non-deterministic finite automata, but in this video we are going to see the next subtype of NFA, which is a NFA with epsilon transition. So let's get started. Basically NFA with epsilon transition is a next extension of FA. NFA is allowed to make transition spontaneously without receiving an input symbol. That means your automata is allowed to change its state without reading any input symbol. That's why it is called as a epsilon transition, which gives the empty string, right? So, in case of our simple NFA, we have seen that the choices of moves for a particular input from a given state or current state to a next state is different. Like we had an example from our Q0 to Q1 and from our Q0 to Q2 we are carrying the same inputs, right? For a particular input A from state Q0 we go to the state Q1 and Q2. That means we have to compulsory carry any input symbol from a current state to a next state, right? But in case of NFA with epsilon transition, for going from one state to another state, it is not mandatory to scan any input symbol. That means you can go to the next state using epsilon only. Epsilon means a null string, right? So both NFA and NFA with epsilon recognizes the exactly same language. Exactly same language, that means a regular language, right? So NFA and NFA with epsilon representations, that means the graphical representations are different, but it carries the same language. Okay, so let's see its formal definition. So formal definition of epsilon NFA, it also has 5 tuples Q, sigma, delta, Q0 and F, right? So here your Q, Q0 and final state, all 3 tuples remain same, but only there is a slight change in a sigma and delta. So sigma, basically sigma is a set of alphabets plus epsilon, which is a null string, right? And in case of delta, it would be union epsilon, which gives 2 raised to q. That means on any state, after scanning epsilon symbol or any input symbols from alphabet, you can make 2 raised to q transitions, right? So let's have an example so that you can understand the concept of NFA with epsilon transitions. So your example would be, your language accepts 0 or more occurrences of A's followed by 0 or more occurrences of B's followed by 0 or more occurrences of C's, right? Here your string would be A, B, C. Initially, as you can say that your string is 0 or more occurrences, that means here your string can be null. That means it would be represented by epsilon, right? So your string is epsilon, maybe A, maybe B, maybe C, or ABC or AB or maybe BC or maybe okay, anything, right. So our NFA with epsilon transition would be start, which is a Q0, then Q1 and Q2, which is a final state. Here you are looping A at Q0, B at Q1 and C at Q2, right. And we are also carrying epsilon from Q0 to Q2. Here you can say that at Q0 there may be 0 or more occurrences of A's, at Q1 there may be 0 or more occurrences of B's, and at Q2 there may be 0 or more occurrences of C's. So in this case, if our string may not contain A's, then our string would start with B's, right. And if also our string would not contain B's, then it would start with a C, right. So that's why we are carrying epsilon here. Like if a string starts with B, then first of all from Q0, as it is the initial state, we can write epsilon here, right. So B and C. If our string starts with A, and if we don't have B's, then it would carry epsilon here, then it will write C. If our string only presents A's, then it will carry epsilon here, and if our string has only C, then it would be epsilon at the initial state, right. So by this way we can draw NFA with epsilon transitions. So let's see the transition table for the same. Sigma Q. Here we are going to write our input symbols A, B, C. Also here we are going to add the next input symbol or new input symbol, which is epsilon, and here we are going to write Q0, Q1, Q2, which are our input states, right. So for Q0 we are carrying A to Q0 itself, right. Q0 don't carry B's, it carries epsilon, that's why we can write here phi. Also Q0 don't carries C, that's why we are writing here epsilon, phi, sorry. So from Q0 we are carrying epsilon to Q1, that's why we can write here Q1. So same from Q1 we don't carry A, that's why we can write here phi. From Q1 we carry B to itself, that's why we can write here Q1. From Q1 we don't carry C, that's why we just carry epsilon here, that's why we can write here phi. And from Q1 we can carry epsilon to Q2, that's why we can write here Q2, right. For Q2 we don't carry A and B, that's why we can write here phi. Also from Q2 we carry C to Q2 itself, and also it don't carry epsilon, that's why we can write here phi, right. So this would be the transition table for the NFA with epsilon, right. So in our next video we are going to see how to calculate the epsilon closures for the given NFA and different conversions like NFA to like NFA with epsilon transitions to NFA. So till then stay tuned and thanks for watching the videos.